A vertical stretch multiplies all y values of a function by the same factor greater than 1. A vertical compression reduces all values of a function by the same factor between 0 and 1. For a function f of x and a constant a, y equals a times f of x is a vertical stretch when a is greater than 1, and a vertical compression when 0 is less than a and a is less than 1. Here we can see a graph. Take note of the original function in blue, f of x. Moving to the reddish-orange function, that would be a times f of x if a were greater than 1, so a vertical stretch. And our green graph shown here is 1 over a times f of x, so a fraction, presumably between 0 and 1, resulting in a vertical compression. Problem 4. Stretching and compressing a function. The table shown represents the function f of x. What are corresponding values of g of x and possible graphs for the transformation g of x equals 3 times f of x? Well, first let's consider our table. X values on the left as inputs, f of x values are outputs on the right-hand side. -5 corresponds to 2, -2, 2, 0, -3, 3, 1, and 5, -2. Step 1. Multiply each value of f of x by 3 to find each corresponding value of our new function g of x. So a new table, our x values and f of x values from above, something of a process column here where we're multiplying the f of x output values by 3 and showing what's going on as we compute our output values for g of x. So tracing the input of -5 through the row, an x input of -5 results in an f of x output of 2. 3 times that, so 3 times 2, is our g of x output, and that's 6. Similarly, for -2 as an input value x, our output from the function f would be 2. 3 times that, 3 times 2, is also 6. So our g of x output value would be 6. Continuing on, we'd have output values for g of x of -9, +3, and -6. Step 2. We'll use the values from the table in step 1 and draw simple graphs for f of x and g of x. So we've plotted the points, f of x here in reddish-orange, connected them with line segments, and then plotted the corresponding points for g of x in blue, again connecting those points with line segments. Your turn, part A. For the function f of x shown in problem 4, what are the corresponding table and graph for the transformation h of x equals 1/3 f of x? And part B, a reasoning item. If several transformations are applied to a graph, will changing the order of transformations change the resulting graph? Explain.